Hello and welcome to Vidra Embedded channel, and also welcome you to the series of video tutorials on getting started with TI-RTOS kernel. So in the last tutorial we have seen how we can create the task using TI-RTOS statistically with the help of a GUI interface, and then we have written a small functions to blink the LEDs using the task. So in this tutorial, I'm going to show you how we can use the one of the feature called UIA, which is also known as Unified Instrumentation Architecture. So this is basically a tracing tool. For example, you take a normal superloop coding. Okay, when you want to debug your code, if something not working. So basically, what we will use is we'll use our debugger, and then we'll go to debug mode, debug our code, and then we can come to a conclusion that where it is actually throwing an error. But in case of an RTOS, it is quite difficult to trace an application. Okay, when you find any issues. Okay, with the help of only the debugger. So the reason being is, okay, once all the initializations are done, when it comes to a bias start, okay, in case of TI-RTOS, okay, so the control will be taken care by the kernel itself. So that time it is very difficult to identify where the error occurs, and then you cannot able to figure it out using only debugger. So that is the reason why. So different vendors provide different tracing features. For example, to name a few, we have a Persevere tracealizer, which is used for many ARM Cortex-M microcontrollers, and then we also have a Sega System U. And I have shown how to integrate the Sega System U with the FreeRTOS. So you can watch my video tutorials on this channel. Since we are using a TI-RTOS, TI has provided a inbuilt feature called UIA, which will provide the tracing features, like how CPU load analysis. Okay, you want to see an execution, how your tasks are executing, how your software interrupts are executing, how your hardware interrupts are working, how semaphore is handovering things. So these kind of things you want to visualize graphically, okay, and to understand your application is working as expected. So we can use these tracing features. So the one such is the UIA, which is also known as Unified Instrumentation Architecture. So moving on. So what is UIA? Again, it's a Unified Instrumentation Architecture. Is a target-sided package that provides instrumentation services. So it is also known as a TI-RTOS instrumentation. Basically, so TI provides a package which will enable the feature of UIA. So going forward, in I may call this as a I may call as a TI-RTOS instrumentation. Both are same. Even in the documentation, you will see both the names. Okay. And instrumentation application is so what are the features that we are actually going to get if you actually integrate this to your application. So see, this is part of sysbias. Okay, so UIA is included in sysbias, and it provides the software instrumentation features like a CPU load, task load, and software interrupts load, hardware interrupts loads. Apart from that load analysis, it will also provide the execution analysis, which means that how your tasks are executing, how your hardware interrupts are executing, how your software interrupts are executing, when the semaphore is actually occurred. So these kind of features are very useful when you are actually writing an application with RTOS, and then you want to trace or debug your application when something goes wrong. Okay, so tracing things are very useful actually in case of RTOS. Okay, where you cannot able to debug your application with normal debugger, how you actually debug with normal superloop code. Okay, so the UIA, and also they provide something called XTC runtime tools. So one of that basically XTC runtime log. Okay, so let me take a pointer. So moving on. So what kind of options we have? Okay, actually, so to use these features. Okay, so there is something called logging setup module. Okay, everything is a module kind of thing in TI-RTOS. Okay, so one such is that logging setup. So this is actually inbuilt in the sysbias, as I said, under ta.uia.sysbias package, and provides the following options in the graphical user interface. You can also use the script. Okay, in the .config file. Okay, so .config file you can use it for both scripting. It's a basically JavaScript. You can use the APIs directly, and then you can use the script, as well as you can also use the xconfig tool to configure this UIA graphically. So it's very easy to configure graphically, so we will go with the graphical user interface. So what kind of logger options we have? So I took this table from the system analyzer user guide table 1.1 from the TI-RTOS documentation. So you can, sorry, it is from the system analyzer documentation, not from the TI-RTOS documentation. Okay. So there are different types of logger types we have. Okay. So JTAG stop mode. So here events and the are uploaded over the JTAG and the target halts. So this is basically stop one, stop mode, stop and execute mode. So you will run the application for some time after enabling the logging setup, and then you will pause the application, and then you will see okay how the events are logged, and then you will able to see all the loads, as well as also you will able to see something called execution analysis. Okay. And they're also providing a runtime mode. Okay, but currently this is not supported in MSP432 or TIVASI boards, so it is only supported in C64X devices. Okay, so with this you can able to no need to pause your application, you can watch it in the runtime while your application is running. Then coming to the non-JTAG run mode, so this is another feature. Okay, again this is events are uploaded on non-JTAG transport such as Ethernet. Okay, and there are some other features also. So one we are interested in this one is a JTAG stop mode. Okay, so basically we will run the application for some time, probably 10 to 15 seconds, and then we will halt the processor, and then we'll try to log the events. Then, as I said, apart from the load features and load analysis, it will also provide something called a graphical user interface, okay, which we also called as a RTOS analyzer. So with this, you can able to check how when the task is actually started, after task whether you see any software interrupt occurs. This kind of graphical user interface analysis you can able to see using the RTOS analyzer, and this is very like kind of a good representation actually I would say. So you can able to find whether your task is running according to your application that you wrote. Okay, so depending on the use case and depending on the your application. Okay, so it is very actually useful in the debugging especially. Sometimes what will happen means in RTOS, okay, suppose one task suddenly is not working, so you should know whether the task is executing at particular instant of time or not. Okay, so that you can able to easily find out using the RTOS analyzer. So open the RTOS analyzer and go for this timing diagram, and then see whether your particular task is running or not. So that way you can figure it out, and then analyze your application where it went wrong. Now, coming to the login setup, how you actually set up in the real-time application. So in the project, we have a .config file, right? So I have shown you how to you open this .config file in the last tutorial using a graphical user interface. Just right click on it and open with Xconfig tool. So here you can see this is a UI login configuration. You can read out this statements here. Okay, and then so this is actually available under once you open this allo.config file, you will also get the available products under. You need to go to TA under sysbias, and here login setup is there. You need to right click and enable it the feature. So I will show you how to add that. Okay, and after that whatever the things that you want actually. So for example, if you want to task analysis, you can click on the task. You want to CSV, like software interrupts, hardware interrupts, semaphores. So these are the different features that they are providing. But okay, you can just check or uncheck to integrate them into your application. Okay. Obviously, it will take some time because logging features required some memory. So that also we will see. Okay. So these are the memory things. Okay. So as I said, we are going to use the stop mode, logger stop mode, JTAG only, and these are the different buffer sizes for the load events, RTOS execution events, and user return log events. Okay. You can increase this buffer size if you have more RAM memory available in your microcontroller. So depending upon the use case and you want to analyze your trace for longer time, then you can increase these buffer sizes. So then after that, once you enable the logging setup, then you need to also enable the enable logs on the BIOS runtime options. Okay, this is very very important. Okay, that's all for the theory. Now we will see how we can enable this feature in the Code Composer Studio. and then we will see how this RTOS analyzer works. Okay, let's get started. Now I have opened the Code Composer Studio. So then this is the project that we created in the last tutorial, and so let me click on this. Yeah, now we were able to see this. Okay, if you don't know how to open this using a graphical user interface, it's very simple. Click on the .config file, open with xg config editor. Okay, that's all. So the first thing first, we need to enable the logger. So as I said, once you open this task.cfg file, it is not available in the another mode. Okay, you see, if I change to main.c file, okay, you are not able to see anything on the available products. Okay, so click on the task.config, and then here you will able to find all the available products. One is related to XTC tools. So the one which we are interested in, TI-RTOS. Okay, so click on the TI-RTOS and the TI. So as I said, it is under UIA, under sysbios, and here we have the logging setup. So yeah, you need to click on this, add logging setup to my configuration. Okay, so it is just taking some time, and by default it actually enables these two features, like CPU load analysis always, and as well as the task context always. So we'll go with the default. Okay, and then come down, scroll down. You will able to see a loggers. Okay, you need to select this. These are the different loggers that I explained to you. So the one which we are interested in, logger stop mode. By default it is taking based on your microcontroller, and these are the buffer sizes. I'll go with this buffer size. Okay, this is pretty enough. Okay, since I have the very less RAM. Okay, in MSP 432 device. If you have a more RAM, then you can increase those sizes, not a problem. Okay, so that's all. Save. So the moment I save, I got one warning in the problem section. What it is showing, so bias.logs enable must be set to true when using RTOS analyzer. So as I explained, so we need to also enable the logs feature. So to enable that, click on this bias in the outline view, and then go to runtime. Okay, and here we have, so click on this enable logs. So the moment you enable the logs, here you see that, okay, the warning is not showing. And so since we configure this in the graphical user interface, right? So let's see how the script look like for this. Okay, just to show you. Okay, let me go to the down. All the things that you enable by user, it will be added at the application specific instances at the end of the config file. So here, uh, okay, these are something related to application specific, and we should see the bias, right? So you see, this is a assertions. No, we were interested in log feature. See, log features are enabled, and the logging setup, somehow it is not showing in the outline. So what I identified is just close this project once, and then double click to open it again, and then open the .config file one more time using xconfig tool, and this time you see the logging setup is shown in the outline view. So you go to script again, and then double click here, it will automatically go here. So this is how the setup is look like. Okay, so that's all for the login setup. Okay, so nothing else, just you need to enable the things. Okay, so in the graphical user interface, just enable the RTOS execution analysis, and of course by default we are going right, so it is also selected the CPU. Just compile the code. We are not changing any application code. The code remains same. Okay, and then we'll see how these tasks are executing in the graphical user interface. Okay, the build is finished successfully without any errors and warnings. Okay, now, so click on the debug button. Okay, it is already at the main. Okay, so let me upload the code. So now the code is running. I could see that both the LEDs are blinking. Okay, with a delay of 200 milliseconds. Okay, and then let it run for some time, probably 10 to 15 seconds, to get the more log events. So I think this is enough. Just click on this suspend button. Okay, it is suspended now. So there are a couple of features I want to show you now. Okay, the first one is the runtime object view. So you can also find it in the tools. Okay, runtime object view, click on it. Okay. So now the runtime object view is open. So this will open a one JSON file. I'll show you that where it is. Currently I'm in debugging mode, right? So once we switch to C mode, I'll let you know that. Okay. So just open a dashboard, it will show, and then it is asking for a rov.json file. Okay. So just click on the all, and then in the project you will see something called overview.rov.json file. Just load that. So it will open a dashboard. Let me adjust this. And here you will able to find all the things. Okay. So let me currently, okay, we'll see one by one. So this is something called task. Okay. So you see we have a task one handle and task two handle. Both are at the same priority. Currently both are blocked. Okay. That is the reason why we see idle task is running. Okay, since these two tasks are blocked, that is the reason why you will see ideal task is running. We will talk about more what is this ideal task, how we can execute some code inside ideal task. Okay, so we have two task functions, task on green LED and task to red LED. And what are this? We have allocated stack size of 512 512 bytes, but it is taking stack peak is 268. So this is very important. You should not provide a low stack. Okay, if you provide for example 250, this won't work actually. Okay, and there is something called hardware interrupts. This also we will discuss about more in upcoming tutorials. Okay, so it uses some timer periodic functions. Okay, for the system timer. And then here it is also showing something called heap memory. Okay, so nothing is showing here. Okay, and then it comes to the stack uses, it is also showing as a graphical user interface. See, total bytes used, total amount of free space is available based on your task. So there is something one ISR task is running. Okay, and this is not by default system configure this one. Ideal task is also running. Okay, this is also system configured one, and task 1 task 2 handles are created by us. So this is how you can look at it. So there is another way, like how you can see the logger setup. So to see what are the different kinds of log events are occurred. Okay, so here go there, click on the logger setup mode. So here go to records. Okay, and then click on the sysbios system view logger, and here you will able to see all the logging features. Okay, let me zoom this one. So you see these are the different events that are logged. Okay, now we will see how the RTOS analyzer looks like. So to open the RTOS analyzer, go to tools, click on RTOS analyzer, and then first you will see the execution analysis. It will take some time to open. Okay, so here you just click on the execution graph, and instrumentation status should look like a good. Okay, so this should be good always. Okay, so then click on start. It will open the live session, and also it will open the something called cortex m4 underscore 0.os. Expand this, and here you can able to see our two tasks, task on LED green LED, and task 2, and as well as we have ideal task as well as a bias scheduler. So here so we are not able to see these two task execution, right? Just zoom out, and here you will able to see. Okay, now we see first when there is no task is running. Okay, and your ideal task will run, since we are using a priority based preemption scheduler. So when there is no other task is running, ideal task will run, and then it will start with the green LED. Okay, and then execution again switch back to the scheduler, and scheduler we again switch to red LED task. Again it will back to the bias scheduler, and then again if they, because since by this time what happens is both the tasks are in blocked state, so that is the reason why you will see ideal task. So in this case most of the times your ideal task is running, so the task underscore sleep function will actually put your task into block state. Okay, for 200 milliseconds. Okay, so that is how you see this is as expected. So this is how my application should work actually. So this is how you can analyze your application graphically and see that your application is running properly or not. So in the live session also you will able to see how the events are occurred. You see here kernel task occurs, it goes to sleep, again it goes to block state. Okay, And that is how it is working. You see here. So these are the different tasks that are actually running, and the CPU load is also you can able to see. Okay, that's all for this tutorial. If you like this video, please subscribe to my channel and also share to your friends and then ask them to watch these video tutorials. Thanks for watching it.